Hi, here we come to the simultaneous equations component of the linear algebra revision sheet that I handed out in my class. You may be not in my class watching this, and I hope you get some benefit from it. Firstly, we're going to be looking at the elimination method to solve two equations. What I'm going to do is I'm going to write the two equations out so that the x's and the y's and everything all line up. So first equation, 3x plus 2y equals 12, and the next one is 2x minus y is equal to 1. Now you'll notice that the x's are lined up and the y terms are lined up. We've got our answers also lining up on the other side, on the right hand side. What we need to do is identify if we have a coefficient of x or a coefficient of y which is the same. So I'm comparing the coefficient of the x's here. They're not the same. Now if I look at the coefficient of y's, neither are they the same. So we've got 2 and 1 now. What we need to do is to try and make them the same. So it's a little bit like getting a lowest common denominator with fractions. Same sort of thing. We've got to try and work out the easiest way of making some of these coefficients the same. So if I were to make the x coefficients the same, what we could do is we could have multiplied the first equation by 2, which would then make that 6x, and we could have multiplied the second equation by 3, which would then make that also 6x. But if I can then compare the y ones separately to that, I could just multiply the second equation by 2 without changing the first one, and that would also meet our ends. So that's what we're going to do. The first equation, we're just going to rewrite this one. It's 3x plus 2y equals 12. And for the second equation, I'm going to multiply everything by 2. So 2x times 2 gives us 4x. Minus y, or negative y, times 2 is negative 2y, equals, and then 1 times 2 is 2. So now if we look at it, our y coefficients have the same magnitude, the same size, same value. It's a different sign, but that's fine. So what we now need to do is look at the two terms there and think to myself, how am I going to get rid of them if I either add or subtract? How will they cancel down, or how will they be eliminated? And if I add those two terms together, positive 2y take away 2y, then it will equal 0. So that tells me with these two that I need to add these two equations together, and that will then eliminate the y's. So essentially it works out that for these ones, if it's the same sign, so they're both positive or both negative, if it's the same sign, then subtract. If it's a different sign, so one of them's positive, one of them's negative, then we add them together. So that's the case we have here. We're going to add them together. So we have 3x plus 4x is 7x. Plus 2y, take away 2y is 0. So we'll just write that as plus 0 equals 12 plus 2 is 14. So we now have our equation. We can ignore the 0 in the middle there. We've got 7x equals 14. And then we divide both sides by 7, which will then cancel that down. It gives us x is equal to 2. What we then do with that one is we substitute that back into one of the original equations. So what we'll do is we'll substitute that back into equation 1. And I'll do that over on the left hand side here. So if I write the first equation out, and then I'm substituting x equals 2 into that, that gives us 3 by 2 plus 2y equals 12. So 6 plus 2y equals 12. Now we do our reverse operations, or inverse order of operations. So we've got a positive 6 at the front, so we'll take away 6 from both sides to get rid of that 6. Leaves us with 2y equals 12 take away 6, which is 6. And the next thing that we do is we divide both sides by the 2 to cancel that down. That will then give us y is equal to 3. So we've got y equals 3, we've got x is equal to 2. Now it's always a really good idea to check your answer. Now let me get another colour pen here. And what we're going to do is to throw both our x and y values that we've found, and we'll put them into the second equation up here. So our second equation, we've got 2x. I'll actually write that as our check. Check the answer. 2x take away y equals 1. So we've got 2 times 2 take away 3 equals 1. So 2 times 2 is 4, take away 3 is 1, which gives us 1 equals 1. So therefore our left hand side equals the right hand side, and all is hunky-dory. So that tells us that our answers are x equals 2 and y equals 3, or we can write our answer in coordinate form, which is 2, 3. And that's our answer. Okay, we'll move on to the next question. Same sort of thing here, solving simultaneous equations, but we've actually been specified to use the substitution method. What is the substitution method? That's where we're going to substitute a component of one equation with that component in the second equation. What does that mean? We've got our two equations here, 3x plus y equals 17, and we've also got y is equal to x take away 3. I'm labelling this one equation 1 and equation 2, and to substitute, this is quite easy. What we're going to do is we'll substitute 2 into 1. That essentially means that we've got this y part in the first equation, and we see y is equal to in the second equation. So essentially what we're going to do is we're going to replace the y part in the first equation with everything on the right hand side of the second equation. So that's all going to go into there. We're substituting that in. So I'm going to rewrite this. We've got 3x plus y equals 17, but y is equal to x take 3. So therefore we have 3x plus, so instead of y, I'm just going to put a little bracket here, x take away 3 equals 17. The reason I put a bracket in there is it's more important if this had been a takeaway, because this would then be applied to both of them. So you could sort of treat it a little bit like plus 1 times by x and plus 1 times by negative 3. If it was a negative, you'd have to make them both negative of what was inside the bracket. So I'll just simplify that now. 3x plus x take away 3 equals 17. Now collect our like terms, so I've got 3x plus x is 4x. Take 3 equals 17. Now we're going to add 3 to both sides, which cancels that down. Leaves us with 4x equals 20. And then we divide both sides by 4 to cancel that down. That leaves us with x is equal to 5. Okay, so that's our first answer. Then what we need to do is we want to substitute this into equation 1. So if we sub x equals 5 we'll put into the second equation, because that's y equals. So we've got y is equal to x take 3, but x is equal to 5, so that'll be equal to 5 take away 3, which is equal to 2. So our second answer that we have here is y is equal to 2. And as I said a moment ago, we do a check, make sure it works. So we'll substitute them both into the first equation. So our little check. What we need to do there is, we've had the substitutions gone into the second equation, so we do the check with the other equation. If we had a substituted into the first equation, then we do a check with the second equation. So with our check, we've got y is equal to x take away 3. We'll substitute in the values we know, so y is equal to 2. And we have x equals 5 take away 3. So 2 is equal to 5 take away 3 is 2. So therefore the left hand side equals the right hand side, and everything is all good. Okay, so everything's worked out beautifully, and that tells us that the answer is, in coordinate form, 5 and 2. Either you could have done that, or you could have written it separately as the y equals 2 and the x equals 5. Let's move on to the next one. Solve using a graphical approach. Okay, I'm going to use the y-intercept and gradient method for this. So for the first equation here, 2x plus 1, the plus 1 is our y-intercept. And that's our gradient, so m equals rise over run, which equals 2 over 1. Turn it into a fraction. If it's not a fraction, put it as a fraction over 1. Okay, so I'm going to plot those points there. So we have a y-intercept is equal to 1, right there. And for the rise over run, we're going to go up 2 and across 1 to get to our second point. And now we need to draw a line through there. Let's see if I can do this. So there's the line for the first equation. Now for the second equation, we go through the same procedure. We've got minus 2, c equals the y-intercept, which is negative 2, which that's here, and our gradient dogs have discovered something out there, so we'll turn that into a fraction over 1, 3 over 1. So we need to go up 3 from our y-intercept and across 1 to give us our second point, and again I'll draw a line through there. Now that I've got my second equation, a second line drawn, we now look for the spot where the two of them cross over, which that happens to be up here, and that occurs at y is equal to 7 and at x is equal to 3. So the solution to this one is going to be x equals 3 and y equals 7, or 3, 7. It's always good to do a check algebraically after we get the answer if you can, and I'll just use the first equation up there. So for our little check, we've got y equals 2x plus 1, but we know that y is equal to 7 is equal to 2 times x is equal to 3. So 7 is equal to 2 times 3 is 6 plus 1 is 7. So we've got left hand side equals right hand side. So that was just a little algebraic proof. Everything's okay. But we've obviously drawn the graphs here. It's good to check that your graph is right while doing a little algebraic sum. Let's move on to the next one. Same thing using a graphical approach. We've got y equals 2x plus 1 and x is equal to negative 1. So I'll draw the first graph here. So we've got plus 1 as our y-intercept right there, and m equals 2 over 1. That comes from that, so 2 divided by 1 is 2 as a whole number. We're going up 2 and across 1 to give us our second point. And I'll draw this line in. And the second graph that we have is, whoops, put that all back to where it was. That was interesting. Like that. Okay, so the second one that we have, x equals -1, that is a line which just passes through x equals -1 and goes straight up and down. So it doesn't matter where it is, it's always x equals -1. So that's going to be a vertical line, so I'll draw that one in there. Now that we've drawn that in, we need to look for the intersection point, which is right there. That occurs obviously at x equals -1 because x has to equal -1, and also at y equals -1. So our intersection is at -1, -1, and we'll just do a little check to make sure that that's correct by throwing it into the first equation. Y equals 2x plus 1. Y is equal to -1 equals 2 times x is equal to -1 plus 1. So -1 is equal to 2 times -1 is -2 plus 1. Left hand side -1 is equal to right hand side -2 plus 1 is -1. So we have left hand side equals the right hand side, so everything is good. So our answer is true. Okay, now last question. Don't you hate these worded questions? Okay, let's have a look through this. Julie and Anne are gardeners. They buy 2 sorts of plants from a nursery, some for $3 and the rest for $5. If they spend $180 buying plants, find the number of each plant purchased. So what we need to do is set up something to identify the 2 different sorts of plants. So if we say we'll let X represent the $3 plants and Y will represent the $5 plants. And it's the number of plants. Okay. So I should say X is the $3, that's the number of. And that'll be for both of them. Okay, what we now need to do is to set up 2 equations. So what do we know about these 2 equations? So we're told that there is a total of 50 plants. So from that information, we've got x plus y will equal 50. Then for the other equation, it tells us that they spend a total of $180. So for the $180, we're going to have x lots of the $3 plants, so we'll call that 3x, plus y lots of the $5 plants, so 5y, and that will be equal to the 180. So they're the 2 equations that we have. That's equation 2. And we have equation 1. Then it's up to you how you want to solve those 2. You can either solve them by substitution or you can solve them by elimination. I've already got them set out nicely for an elimination equation. So in this case here, what I want to do is to compare the coefficients. So if I look at the x coefficients, nothing's the same. The y coefficient, again, nothing is the same. So I will make the x coefficients the same by multiplying the first one by 3. So that way everything in the first one by 3, we have 3x plus y times 3 is 3y equals 50 times 3 is 150. Then for the second equation, we don't actually need to change anything in that because we've got 3x at the start there, and the whole point of this little manipulation was to make the x coefficients the same, so we've got 3x plus 5y equals 180. Now comparing these two coefficients together, they're both positive. So what I need to do, if they're the same sign, is to actually subtract the second equation from the first equation. So if I go 3x take away 3x gives us 0x. Then if I go 3y take away 5y, that's negative 2y equals, and 150 take away 30 is negative 30. The next thing I want to do with this, I can ignore that 0, so I divide both sides by negative 2. And the 2's cancel down, the negatives both cancel down, and the negatives will also cancel on the right hand side as well, which leaves us with x is equal to 15. Then what I want to do with that, y is equal to 15, I'll substitute that back into the first equation. So we'll sub y equals 15 into 1. So I'll write out the first equation here. We've got x plus y equals 50, but y is equal to 15, so that goes into there. So we have x plus 15 is equal to 50. Now if we take away 15 from both sides, that gets rid of that, which leaves us with x is equal to 50 take away 15 is 35. So we have an answer now of x equals 35 and y is equal to 15. And as I said before, what we need to do is to check that. So we'll check in the second equation. The second equation that we have is 3x plus 5y equals 180. X is equal to 35, so it's going to be 3 times 35 plus y is 15, so it's 5 times 15 equals 180. 35 times 3 is 105 plus 15 times 5 is 75. So we get now 180 equals 180. So our left hand side equals the right hand side, so everything is good. So that tells us our answer. We're going to have x is 35, so we've got 35 of the $3 plants. And we have got 15 of the $5 plants. And that's our answer. Okay, hope you found that useful. See ya.